Hey, what's up, guys? This is Sheng here again. This time, LeetCode number 2025, maximum number of ways to partition an array. Okay, so this time we have a integer array here, and then our task is to partition these numbers. We need to find the number of ways to partition the numbers, so that we have a pivot here, so that the left part and the right part have the same total, right? So our definition is the pivot index is starting from 1, right? Because we need at least the left part and right part. So we have this array here, So the index is something like this. So if this is the pivot, right? So the left part is this one. The right part including the current index. Okay, and we need to find how many pivots that can partition this array so that the left part and right part are the same. Right? I mean, if it's just that, this one will be an easy problem, right? Because we can easily enumerate the each index, and we can use a prefix to quickly get the prefix and suffix, so that we can check their total, right? But this one we're also given like an integer k, right? Which means that for this one we can choose at most one element, and we can change this number to k, right? Or leave the array unchanged, right? And then, yeah, so that's that. That's why, for this one, in example 1 here, we have 2 minus 1, 2. If we don't have this k, the answer will be 0, because there will be no index that can partition this array so that the left part and right part are the same, right? But now we have given like another k here, which means we can choose any one number and then change that number into 3. That's why the answer for this one is 1 instead of 0, because after changing the first number from 2 to 3, right? And then we can partition it like this, right? This is a partition. That's why we have 1 here. Yep. And here we have in example 2 here, right? I mean, this one, it means that even though we have a k here, the optimal solution is we don't change anything, right? So in this case, we have 2, because we can partition it in these 2 ways. Okay. So that's it. The constraint is standard 10 to the power of 5, right? And this one is also 10 to the power of 5. Cool. So like I said, the brute force way is what? The brute force way to verify this number, this k number, is we just need to change each number into this k, right? After that, we check each of the index, right? So how many index we can partition this array, right, into 2 equal parts after changing this number into k, right? Apparently that will be a n squared time complexity, right? Because we have n numbers in total, right? And then for each of the n numbers, we will need to check each of the index. That's why the total is going to be n squared, which will TLE, right? So that's why we need to find a better way, right? And so how should we solve it, right? If apparently we still need to check each number once, right, separately, which means we still need to check after changing this number to k, what's going to be the valid pivot index, right? But if we can, but instead of after changing this number to k, instead of checking each of the index in each of the pivot, if we can quickly get the total count, that would be great, right? And how can we do it, right? And so the way we can do it is like this. Let's say we have this kind of numbers here, right? We can easily get the original difference, right? we can quickly get the difference at each of the pivots if we don't change anything, right? And we can store that into a dictionary, right? Basically, we have this one. This one will have like a difference, right, from the left part and right part. This one the same, right? So on and so forth. Okay, let's say we pre-calculate that the difference from so the difference is what? The difference equals to the prefix uh, pre prefix subtract the suffix, right? So that's a difference, and we can pre-calculate this difference for each of the index here, right? And then we store it into a dictionary. And after that, right? So basically, this is going to be a counter of the dictionary, right? Because multiple index could lead to the same difference here, right? And after that, let's say we change this number. Let's say there's like this number 4. Okay. Let's say if we change this 4 into 10. Okay. Basically this is k, right? So if after changing this 4 to 10, what does it mean? So it means that okay, all the suffix. It means that all the suffix starting from 4 will be increased by 6, right? Oh, so this one the difference will the difference is 6 in this case, right? So basically we're increasing this 4 by 6 into 10. So this means that since keep in mind, so we have a prefix subtract suffix here. It means that any suffix on the left of 4, okay, on the left of 4 will be increased by 6, right? And on the other side, all the prefix on the right, basically this is a suffix, right? And all the prefix on the to the right of 4 will be increased by 6, right? So as you guys can see, so basically, depending on the index, in this array, right, and comparing with the current one, let's say the current one is I, this one is I, right? And okay, so the suffix, right? So anything on the left side of the suffix, basically the suffix smaller than I, right? Suffix increase by 6, right? Where the j is smaller than I, right? Yeah, and the prefix, yeah, this is equal smaller, or the prefix increase by 6, where the j is greater than I, right? So this one, so here the reason we have a smaller or equal and this one is greater is because the definition of prefix, right? So now as you guys can see, basically depending on the index of the original difference, right? Either the prefix will be increased by 6. Of course this one could be decreased, right? But we're using this increase as an example. So either the prefix will increase by 6 or the suffix will increase by 6, right? So then it means what? So this means that, let's say the original index, the original difference, let's say if the original difference of some index is equal to 6, okay, then it means that, if the suffix is increased by 6, and then after changing this I, right, this 4 into 6, and then this one will becomes to 0, which means, okay, we find a pivot, right? Or another way is what? Another way is that, if the original difference is equal to -6, right? Because, for example, if the original difference is like uh, 13 minus 7, right, equal to 6. If this is original prefix and suffix, after changing this one, since for example, this one suffix increased by 6, right, this one will become 6. Or if there is like index where the prefix in this case is 7 minus 13, right? If the original one is -6, in this case, if the prefix is increased by 6, then this one will also become to 0, right? So as you guys can see, so all it matters is the original difference, the value of the original difference at each of the index, and will depending on which number we want to change it, or different index, we need to find uh, the original value or the negative original value. How many of them, depending on the left side and the right side. Okay. Uh, yeah, I think so. That's it, right? Basically, so if we go back to this one, right? If we go back to this one, uh, so if we have two count for the left side and the right side to store the original difference, right? It's gonna be a left count, right? Left count. For example, this one 6, right? Plus the right count 6, right? Left count 6 and then the right count 6. And how do we get the left count and right count? Apparently, at the beginning, everything is in the right count. Okay, because we haven't changed anything, right? So after changing the first each of the element, right, we can move the current the current difference, right, to the left count. Oh, sorry, this one is going to be a left count -6, right? Because like I said, the prefix here in this one, we need to have the left count is like the 6, and the right count we are looking for the -6. So the reason being is like this, right? So right means anything that's on the right side of the index I. So in this case, the prefix is increased by 6, right? And in order for us to get 0, we need this scenario, which means that we're looking for the -6, so that we can get 0, right? And for the left side, is anything all the index on the left side of this I here, which means in this case we need we're looking for the actual 6, because on the left side the suffix is increased by 6, right? That's why we can use the original 6 to get that, right? So now the only thing left is that how to maintain, like I said, at the very beginning, everything is in the right count, and every time after processing a current number here, we can just move this one difference from the right to the left. right? So that we can, while processing each of the numbers, we have both the left count and the right count. Okay. Okay. Let me start coding, right? And then maybe, well, after you guys seeing the code, maybe it will make more sense. So we need the pre-sum list to start, right? We can use accumulate in Python, right? And we convert it into a pre-sum. And then we have a right count, gonna be a default dictionary, or we can, let's just use counter here, okay? And then left count equals to counter. Okay, so this one, the count, right, of each original, right, pre-sum minus prefix minus suffix, right, on the right side of the current index, including, right, including index I, including current index, okay? And the left counter is on the left side, okay? Not this one, not including, okay? Not including the current index. Okay. And then we have n is equal to the length of the nums, right? Here, let's populate this right count, because at the beginning we store all the original difference, right, at each of the index to this right count, which means we're gonna start from 1 to n. Okay, so the difference will be pre-sum, right? Pre-sum I minus 1, right? So this is a prefix, right? The prefix is like this because we have this one. This is I, right? So the prefix on the left side, the prefix is this one. Suffix is this. Suffix is this. That's why the prefix is I minus 1, and suffix is what? Suffix is pre-sum minus 1 minus this one, right? So this is a suffix. And then we store this one into the right dictionary, right? And then basically we store the frequency of this difference number here. And so the first one is that if we don't change anything, right? So if we don't change anything, if we don't change it, so we are looking for the difference equal to 0, right? So we can simply use the right count to populate the answer, okay? Any number, okay? So now try to change each number, okay? So here we need to we start from I into range of n here, okay? So the difference, so by changing the current number into k, we have a difference equals to, let's call it d here, okay? K minus nums I, right? So here, like I said, by changing this current I into from 4 to 10, right? So we have 2 parts, right? So the answer will be the max of answer dot the left count, right? Left count of d, right? Plus the right count of minus d. Okay, right? And after processing this one, right, we need to move we need to move uh, we need to move the difference, right, for this in which including this current one in from right side to the left side, right? Because let's say we are after processing this one, right, and the next one will be this one, right? So the next one will be this one, which means we need to move the difference including this one into the left side, which means that the difference for this one is what? Difference for this one is the difference at this location, right? And this location is I plus 1, right? So which means we have to do something like this. So if I is smaller than n minus 1, then we have original difference equals the pre-sum. Basically, we need to use this one, right, to move it from the right side to the left side. But like I said, since we're processing the difference, which including this one, which means that's the difference on the next index, which is I plus 1. That's why we have to change this one from I minus 1 to I, right? And then we have a left count of the original difference increased by 1, right? And then the right side of the count original difference decreased by 1. And then in the end, we return the answer. Right. So I know though this part is a little bit tricky because like I said, when we are at the current index I here, right, we need to find, we're relying on the difference, the original difference on the left side and on the right side. Okay, right, and in order for us to get the original difference on the left side, after processing the current index, right, we need to move the difference of the current one, right, from the right side to from the right count to the left count, and the difference for the current one is what is a difference of this one. Yeah, actually, I think we don't need this this if condition here because since the I will always be valid, right? I think we can just simply remove this one. Right, again, so this part is what? So after processing the current I here, right? We want to move the difference. The difference we want to get ready for the next index of I plus 1, right? And so to calculate the difference, the original difference for the current I here, right? We need to do because you remember, see, so the way we're calculating the original difference is we do a prefix pre-sum I minus 1, right? But so that since we need to calculate the original difference for the next index, that's why we simply just changing the I minus 1 into I, right? So that we can get ready for the next index here. Cool. So if I run the code here, accept it, and let's see. Yeah. So it works, right? Because because the time complexity is what? So we have a for loop here. We have two for loop here. That's why the time complexity is O of n, right? And how about space complexity, right? So we have the right count, right? We have a two dictionary here, and then we have a prefix list here. Since we only have like 10 to the power of, we only have n numbers, so that's why the total difference, the total possible different numbers here in this right count is also gonna in the range of n. That's why the space complexity is also O of n, right? Yeah, I think that's it. I mean, this one, I know this one is a little bit tricky, especially for the part where you need to maintain two counts, right? One for the left side and one for the right side, and also this part, the movement parts, right? Where you process the current I here, right? And after processing the current I here, you move this count original difference from the right side to the left side. And the way you're moving this one is that you have to use the difference for the next index to calculate the current one, because the next index, we have the left part is the one that including the current number. And yeah, I think that's it for this one. And thank you for watching this video, guys, and stay tuned. See you guys soon. Bye bye.